Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos.
Lesson 5. Operation on rational numbers. Addition. The addition of rational numbers is similar to the addition of fractions. Methods of addition. Case 1. To add two positive rational numbers with equal denominators, simply add the numerators and divide the sum by the common denominator. For example, 3 upon 5 plus 4 upon 5 is equal to 3 plus 4 upon 5 is equal to 7 upon 5. Case 2. To add two given rational numbers with equal denominators, if any with a negative sign in the denominator, first convert each of them into a rational number with a positive denominator. For example, 4 upon 9 plus 1 upon minus 9 is equal to 4 upon 9 plus minus 1 upon 9 is equal to 4 plus minus 1 upon 9 is equal to 3 upon 9 is equal to 1 upon 3. Case 3. To add rational numbers with unequal denominators, first find the LCM of the denominators of the given rational numbers. Then, write the equivalent rational numbers of the given numbers with LCM as the denominator. Now, since the denominators are same, add the numerators. Add 1 upon 2 and 1 upon 4. The LCM of denominators 2 and 4 is 4. Therefore, 1 upon 2 is equal to 1 upon 2 multiplied by 2 upon 2 is equal to 2 upon 4. And 1 upon 4 is equal to 1 upon 4.
Therefore, 1 upon 2 plus 1 upon 4 is equal to 2 upon 4 plus 1 upon 4 is equal to 2 plus 1 upon 4 is equal to 3 upon 4.
Additive inverse. In general, minus p upon q is the additive inverse of p upon q, such that p upon q plus minus p upon q is equal to 0. You know that minus 7 plus 7 is equal to 0 and minus 3 upon 5 plus 3 upon 5 is equal to minus 3 plus 3 upon 5 is equal to 0. You also know that minus 7 is the additive inverse of 7. Similarly, in the case of rational numbers, minus 3 upon 5 is the additive inverse of 3 upon 5 and vice versa. Subtraction. When you subtract one integer from the other, you add the additive inverse of the subtrahend to the minuend. The same method is followed in the case of rational numbers. For example, 3 upon 5 minus 1 upon 4 is equal to 3 upon 5 plus minus 1 upon 4 is equal to 3 multiplied by 4 plus minus 1 multiplied by 5 upon 20 is equal to 12 plus minus 5 upon 20 is equal to 7 upon 20. Multiplication. Just like fractions, to multiply two rational numbers, multiply their numerators and denominators separately and write the product as product of numerators upon product of denominators. Thus, for any rational numbers p upon q and r upon s, p upon q multiplied by r upon s is equal to p multiplied by r upon q multiplied by s. Multiply 5 upon 16 by 3 upon 4. 5 upon 16 multiplied by 3 upon 4 is equal to 5 multiplied by 3 upon 16 multiplied by 4 is equal to 15 upon 64. Reciprocal of a rational number. If the product of two rational numbers is 1, then each one is called the reciprocal of the other. Hence, if p upon q is a rational number, then q upon p is its reciprocal or multiplicative inverse. P upon q multiplied by q upon p is equal to 1 is equal to q upon p multiplied by p upon q. Reciprocal of 0 does not exist because division by 0 is not defined. The reciprocal of minus 13 is 1 upon minus 13, since minus 13 multiplied by 1 upon minus 13 is equal to 1. minus 5 upon 8 multiplied by 8 upon minus 5 is equal to 1. Division. To divide one rational number by the other rational number, multiply the dividend by the reciprocal of the divisor. Divide 8 upon minus 3 by minus 5 upon 2. 8 upon minus 3 divided by minus 5 upon 2 is equal to 8 upon minus 3 multiplied by 2 upon minus 5 is equal to 8 multiplied by 2 upon minus 3 multiplied by minus 5 is equal to 16 upon 15. Representation of rational numbers as decimals. To convert a rational number into a decimal, either we follow the long division method or by expressing into an equivalent rational number with denominator as 10, 100 or 1000, etc. Represent the rational numbers as decimal. 1 upon 2. To convert 1 upon 2 into equivalent rational number with denominator 10, we multiply the numerator and denominator of the rational number by 5. 1 upon 2 is equal to 1 upon 2 multiplied by 5 upon 5 is equal to 5 upon 10 is equal to 0.5. Terminating and non-terminating repeating decimals. The decimal representation of rational numbers which have finite decimal part or for which the long division terminates are terminating decimals. For example, 0.5, 0.75 and minus 0.625 ends after certain number of non-zero digits. Thus, the rational numbers 1 upon 2, 3 upon 4 and minus 5 upon 8 are terminating decimals. Sometimes while dividing, the steps of division go on repeating or repeats after a certain pattern of digits. Consider the rational number 1 upon 3. On further division, you will get the same remainder, 1 in each step, and the division process does not terminate. You have also observed that the digit 3 in the quotient repeats itself a certain number of times. Such decimals are called non-terminating repeating decimals. To denote such decimals, we place a bar over the repeated digit. Therefore, 1 upon 3 is equal to 0.3 bar. Thus, every rational number can be expressed as either terminating or non-terminating repeating decimal. Finding terminating or non-terminating repeating decimals without division. Rational numbers, P upon Q in its lowest terms. Terminating decimals, the only prime factors of Q are 2 and 5. Non-terminating repeating decimals, Q has prime factors other than 2 and 5. Without actual division, classify the rational number as terminating or non-terminating repeating decimals. 5 upon 32. Reducing 32, denominator of 5 upon 32, as the product of prime factors, we get 32 equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. 2 is the only prime factor in the denominator. Therefore, 5 upon 32 will have the quotient a terminating decimal. Representation of decimals as rational numbers. For a terminating decimal to be converted into a rational number, we follow the same steps as in the conversion of decimals into fractions. In the denominator, we place power of 10, which is a 1 followed by as many zeros as the number of digits after the decimal point. Now, cancel the common factors if any and reduce it into simplest form. Thus, the rational number is said to be in the standard form. For example, 0.25. 0.25 is equal to 25 upon 100 is equal to 1 upon 4.